Hi everyone, welcome back to Workshop, and no, it's not repair time today, it's actually software development time. And I just thought I'd take the opportunity to let everybody know about some upgrades I've done to Win GPIB. Now if you haven't seen this application before, Win GPIB is an application for Windows for controlling GPIB devices in your workshop. I developed this from scratch a number of years ago now, and I've been tweaking it over the years, adding extra functionality in. But the recent functionality that I've added, I thought was worthy of a video. And so what I'll do now, I'll just actually start logging from the R6581T. I've got it set up here, the pre-run commands here for setting up the DC voltage range, NPLC, that sort of thing. And I'm going to sample it at 1 sample a second. That should be well good enough for MPLC 10. So I'll just hit that there. And you can see it's communicating there. You can see the command being sent out, the response coming back, and the decimal equivalent there. So the next tab along is the command line tab, which you can actually send commands back and forward to your device. You've got the meters tab here. It just gives a large display, especially if you're running Win GPIB on a PC at the other end of your workshop. It's just handy to see it in large text. You've got the temperature and humidity tab here. There's my temperature sensor. It's running right now, and you can see it communicating there. You've got several protocols that you can interface to, mostly the dog Ratian temperature and humidity sensors, but there's an Adafruit offering there as well. And also you can design your own. If you've made your own serial or USB powered temperature and humidity sensor, you can work out the protocol here and it should be able to communicate with it. Then you've got the data log screen here where you can log the logging data to this box here and also save it to CSV. So I can just kickstart that now. You can see it coming in there. Temperature, humidity and the value from the R6581T. So I'll just stop that actually. Then you've got the live chart. So I'll just enable that, R6581T, and I'll enable the temperature as well. And just a live chart here. You can see the data starting to come in here. I've set it up for a 300 x-axis scale point, so there's 300 points from left to right there, so you can change all that. You can also set up auto scalings. I'll just enable that now, and you can see that there it's detected the maximum and minimum there. And you've got the temperature in red there, and the device one R6581T in yellow. The playback chart is for reading back saved off CSV files, so I can just load in one of them now. Let's have a look, CSV, and I'll just log in this one here. You can see that there. In this particular case, I've got a device one, which is my 34461A and my HP3458A. Then there's a few tabs here for actually interfacing with specific devices. And this one here, the 3458A, for saving off the calibration data within the actual 3458A for the calibration and the settings RAM. And a similar feature for the 3457A. And on the next tab along, basically the same thing for the Advantest R6581T. In this case, I can read off and save the calibration data, but you can also upload it as well. And the next tab along is an actual feature for calibrating an HP3245A universal source. And you actually need a DMM, a multimeter, to do that, and you can select from one of three: 3458A, 34461A or 70A, and the R6581T, and that will go off and automate the procedure for calibrating the HP3245A. Because if you've ever calibrated one using the manual and doing it manually, it's a bit of a procedure to do, believe you me. So that's actually fully automated here. Just hit the button and off it goes. And down at the bottom here, I actually put on some controls for controlling an HP3245A, just the basics for the various modes to save you using the front panel on the actual universal source itself. The next tab along was actually a tab for calibrating PDVS2 minis when I was in production of them. And that tied in with the HP3458A, and it went through a number of steps here in order to do that. There was a lot involved in doing it if you were going to do it manually, and I automated that here, so I don't really use that nowadays. Then we'll skip the user tab because that's the one I want to talk about. Then we've got a settings tab just for saving off different various options within Win GPIB, and an about tab at the back where you can actually donate via PayPal to me, because Win GPIB is free to download. But the tab I want to talk about is actually this brand new user tab. And the reason I made this is because if we go back to the 3245A tab here, you'll see that I put down some controls for the HP 3245A, but they're burned into the app effectively. You can't modify this screen, or I could because I've got the development software, but for the general user you can't change this. If you wanted to add an extra button to make use of an extra feat within the HP 3245A, you can't do that. So I thought, wouldn't it be great to have a user tab where the user themselves could actually very easily create any layout of any amount of controls for any test instrument. And that's what I've gone ahead and done. Now, of course, when you first load up Win GPIB, there's no configuration loaded. You've got a button at the left hand corner here for pulling in the configuration file that you've written for the device that you want to control. And it's a simple text-based configuration file to build a complete custom control panel. So I'll just bring one in now. And there we go. Here we've got a file called R6581T-Demo1, and that's all there is to it. It's just a line item configuration file. If you want to put a button on the screen to go and set DC voltage mode, and here it is here. There we've got a button. You've got the GPIB command that you want to send to the R6581T. You've got the location of the button on the actual user screen, the X and Y coordinates, its size, and of course what you want to name the button. But of course there's more than just buttons. There's a whole host of different controls that you can add to that screen. And you can see down here I've got a few loaded on this demo, a few buttons, text boxes, check boxes, a trending chart, a few text labels, drop down menus, a radio group with a bunch of radio buttons inside it, a slider, a couple of horizontal and vertical lines, a spinner, an LED, and a toggle there at the bottom. Now, before I actually load this one in and show you what it actually looks like, I just want to point out that I have actually written a PDF guide for exactly how to do this. And there are all the different controls that you can actually go and configure in that configuration file. And each one has got its own page within the PDF for how to control it and how to make up that entry for the configuration file. The button, the text box, text area, query buttons, all sorts. So let's load in R6581T Demo 1 and let's take a look at it. So I'll just do load here into the devices folder, and there it is there, and that's it loaded and it's ready to go. Now this one here I just threw together as a bit of a demo for all the different controls that are available for the R6581T, or most of them anyway. Now as you can see, it's not doing anything right now. I'll go back to the devices tab. Now I was actually logging there for a second. I'll just stop that because all you need to do is connect to the device. Just hit the connect button here and that's all you need to do. Then go back to the user tab, load in the configuration file, and then if I hit the read button here, you can see it's done a read. I've got this read button here configured to go and grab the latest DC voltage value from the R6581T. But of course you don't want to sit here and press this button all the time. So I've I've got a feature where one of the checkboxes is configured that every half second it'll go and grab a new value. So I'll just hit that now, and you can see I've got a live value here. The chart started to update, and of course you've got some control buttons here for setting the different ranges on the R6581T. I've configured a few for changing LPLC, either via buttons. You can do the same via the pull down here. I've configured that one there. You can see it's speeded up a little bit there. Or you can use a slider to do exactly the same thing. All sorts of different methods. Change the range via the radio buttons as well as the buttons. It's all pretty flexible. But that's just one of the basic ones I threw together just to try and demonstrate most of the different features that are available. So let me just stop that one there. Let's just reset it here using the reset button. That takes us back to a blank config screen here. And let's go and load in the demo number 2. And you can see that this one's a little bit different, but still the R6581T. Got some buttons along the top here for hiding various features. I'll just hit the history button there. We'll come back to that one. You can see that I've configured a whole load of radio buttons here horizontally for the various functions within the R6581. DC voltage mode, AC voltage mode, 2-wire resistance, 4-wire resistance, etc. So let me just connect. Hit the auto refresh button there. And that's it running with the R6581T. I'll just set it to 1 volt mode, 1 MPLC, and that's it running there. You can see the chart along the bottom. You can set the size of it, the color of the trace, everything in the config file. And each one of the functions here, I've got its own NPLC setting pull down there because that's how they're stored in the R6581T. But you will notice I've got a stats panel here. That's another one line item on the config file. A little stats panel. It gives you the maximum, the minimum, the peak to peak, the mean, average, the standard deviation, the number of samples it's read in so far. You can see it's counting, and the ppm deviation on the initial value that was read in when you first started it. But of course you can reset those stats at any time. If I was to change the voltage coming into the R6581T, I can hit reset and it'll start again. Now if we go to these 3 buttons at the top, they're specifically for hiding or unhiding various controls, because you've only got so much room here. So the chart I can actually hide to reveal other stuff underneath it. As you can see, you've got some text there. I can remove the stats if I want to. Now before I actually hit the history button again and bring back that panel there at the start, let me just change it to 10 MPLC just to slow things down a little bit. There we go. And let me just hit that history panel. Now as you can see, you've got the current value coming in at the top, and then they're being moved down every sample. And the size of this, the number of lines, etc. can all be set up in the configuration file. And of course you might want to clear the history to make it start again. There's the count coming in the right hand side there. And whilst we're on about resetting, let me just reset the chart here. Similar thing. So let's take a look at the configuration file for this particular configuration. And here it is here. And you can see there is actually 137 lines of configuration for that display. And the manual, as I said earlier, will run you through each one of these and how to set them up. Now these samples are available for download. They come as part of the installation file when you install WinGPIB. You can see here I've got some linked functions. Well, what are linked functions? Well, if we just go back to the display here, you can see I've got a big text display here. Well, when you set up the configuration file, for instance this historical grid here, you need to tie it to a specific parameter that's coming in from the R6581T, and in this case I'm tying it into this big text here. Same with the stats and the same with the chart. So bringing back the configuration file, you can see that I've got this group of items here. They're all linked together via a common name, and that is, in this particular case, just a word text box result. You can see it appears in various lines there, including the stats panel and including that rolling history grid there. That's what ties them together. And the reason for that, you can communicate with two devices. As I said earlier, Win GPIB is capable of communicating with two devices. So let me set up Win GPIB with my R6581T and my Keithley 2001. So connect to both devices now. There we go. And I'll load up a different configuration. I've got one down the bottom here, R6581T-K2001. So I'll load this one up, and here's one I've just designed. Let me just turn on the auto refresh for both of them. And you can see I've got both the reading from the 6581T and the Keithley 2001 coming in at the same time. I've got a 1 volt source connected to both of them, and I've got two independent charts, and I've got two independent stats panels. And that's made possible if we just bring up the configuration file for it. Here it is here. In this case there's only 56 lines because there's a lot less going on. You can see I've got the linked functions for the R6581T, and below it down here the linked functions for the K2001, and that's what allows you to have more than one device coming into the user tab at the same time. And of course they're totally independent. I can reset the chart for the 6581T and the stats, and the same for the K2001. And of course I can turn off the auto refresh and just do a manual read from the R6581T from its read button, and similarly for the K2001. Okay, that's fine for multimeters, but how about my HP3245A, the universal source? Well, let me go back to my devices tab. Let me just disconnect both of them, change device 2 to my HP3245A, and I'll just connect to it on its own. That's it running now. Go back to the user tab and load up the configuration file that I've written for the HP3245A, and here it is. Very, very basic right now. I've just started to make this one, and so this one's written in such a way to control the 3245A. I can put in a value here 1.5 and set the output of the 3245A to 1.5 volts. And I'll bring up a photograph of the front panel of the 3245A to prove that it went to 1.5 volts. So you can do the same thing for any one of the modes. Set it to high resolution mode, low resolution mode, anything you like. Just open up the GPIB manual for the particular test instrument that you're interested in, and go ahead and write your own configuration file for it. So here is the configuration file for that HP3245A tab that I just written. You can see there's very few buttons in it. There's very few commands in the configuration file. And just while we're at it, I've got another one here. You don't need to have a text box associated with the button here. You could actually set a button up to send whatever value you want without having the text box. So in this particular case, I've got this one set up just to send 5 volts out from the 3245A. But it doesn't stop there. One feature I really wanted to get working with Win GPIB for even the past few years was proper full-blown scripting. So let me just load up another configuration file. This one here, R6581T Demo 4. And this one looks pretty basic. But what I've actually gone ahead and done, I've integrated the entire Lua, L-U-A, scripting language right into Win GPIB. And so to demo that, let me just reset that there. Let's go back to the devices screen. Let me disconnect from the 3245A, and I'm actually going to go and connect up to the R6581T again. There we go, and back to the user tab, and then I'm going to load up another configuration here, a demo one, and here it is. It looks pretty basic, but this is a small demo of how to run scripting in WinGPIB. So let me just pull in the configuration file for this one. And here it is. And the important part here that we want to look at is this lot here. What we've got here is a Lua script, a proper full-blown for next loop with GPIB commands built right into it to communicate with the R6581T. Now of course it's a full scripting language, so there's a lot more you can do with it, but at the moment for this small demo I've just got a simple for next loop. Now the Lua script is stored in the configuration file as I just showed, so I've got a button here that I've configured in the configuration file just to run that script. So let me just hit that button now, and off it goes, and it's doing 5 reads. That's what that for next loop was doing, taking 5 reads from the R6581T and displaying it up on this big text display here. And you can see this is the Lua log, which shows you exactly what was going on. Well, as I mentioned, you can actually do a lot more, so let me just reset that one. Let's go back to the devices tab, disconnect the R6581T. Now what I'm actually going to do, I'm going to connect to both of these, the HP3245A and the R6581T. So connect to both devices there, that's it. And back to the user tab, and then I'll load up another configuration. There we go, and this is one here, R6581T HP3245A Demo 5. Similar looking to the last one, so let's take a look at the configuration for that one. And here it is here, a lot more going on, and a much bigger Lua script. Because what I'm actually doing is I'm controlling the HP3245A to change the voltage, do some readings on the R6581T, change the voltage on the HP3245A and do more readings again. So let's run that one. So I run the Lua from the config file. Ready to go. It's set the 3245A to 5 volts. The R6581T is doing 5 samples on that, as you can see here. And now it's set the HP3245A to 1 volt, and it's going to do another 5 readings, as you can see there. Now of course the Lua language, as I mentioned earlier, is much more advanced than these simple commands that I was writing over here. Let me just turn on the Lua language so you can see that. There we go. Now whilst I'm at it, there is actually one more configuration file that I'd written, so let me just reset that one and load up another one, the demo 3. And that's similar to the demo 4 that I had for the R6581T that just did 5 samples on the meter and displayed the results. And that script was embedded in the configuration file. Well, I've actually got another one here where you can actually write the Lua script in this text box here. So let me just put a script in here. I've actually got it on the clipboard, so I'll just click there and Control V and paste it in. There is the Lua script there. It does exactly the same as the demo 4 one. Run Lua from test box, hit the button, and it does exactly the same, and you've got the same log over here. So that's it, a quick run through of the user tab within WinGPIB. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow.